So let's talk about Cartesian coordinates, which you might be familiar with from math, and why we can't directly use those to map with latitude and longitude. So Cartesian coordinates are pretty simple, right? We have an x direction and we have a y direction in 2 dimensions. And then we have to have some sort of origin. And the origin just means the 0, 0 point, the point where x is equal to 0 and y is equal to 0. And in this case here, it would be just where these 2 lines cross, and that would be the origin of this Cartesian coordinate system. In this case, and is typical, positive x is on this side, negative x on this side, positive y moving upward, negative y moving downward. So why can't we just take a map of the Earth, and we know that we have a 0 point for longitude and latitude already, right? A point of origin for longitude and latitude. We can just put this right here along the prime meridian and the equator and say that's our 0, 0. And then longitude will change in this direction, latitude will change as we move upward. Well, that is fine, and the numbers work out fine, and we could put a point on a map like anywhere, and we could say that so many degrees of longitude this way and so many degrees of latitude that way. The thing we can't do is we can't measure distance on a map like this in miles or meters or kilometers. And part of the reason for that is that this map is a flat map of the Earth, and the Earth is not flat. It's round, it fits on a globe. We're just doing something called a map projection to get it to look like a flat map. And that's not accounted for when we try to measure things like distance. So for example here, remember these 2 lines of longitude are coming together here. All lines of longitude will cross at the North Pole, but that is definitely not what's happening here, right? None of these lines of longitude, these vertical lines are crossing at the North or South Pole. So we're taking a distance that's here, which should be decreasing as we move up here until we get to 0 at the top here. And instead we're extending that to make it just as long as it was at the equator. And that's the reason we can't just use latitude and longitude on a flat map in order to measure distance. One other thing I'd like to talk about with Cartesian coordinates is the way that we measure distance. And this is by something called the Pythagorean theorem. So it's just a little bit of math, right? If you wanted to, if you had any point in this Cartesian coordinate system, let's say here, like here at 3 and 3, if you wanted to measure the distance from 0, 0 to 3, 3, you would measure the x distance to that point, which would be 3. You would square that. 3 squared is 9. You would measure the y distance to that point, which is 3 once again, and you would square that. So that would be 9 squared plus 9 squared. And then to get that actual distance, if you went along a straight line from here to here, you would just take the square root of 9 plus 9, or 18. And that's how we measure distances in Cartesian coordinates.